Hello my dear students, how are you? So welcome back to my channel, Maths for All. This is Sudhakar Reddy. So in this session, we are going to discuss some more models in definite integration. Indefinite integration, not indefinite integration. Okay, so which will be useful for JEE Mains 2020. So let's go without wasting any time. So definite integration. In the last class, we discussed some models. In this class, we discussed some more models. So the first question for today in this session is like this: integral minus 2 plus 2 sine square x whole by step of x by pi plus 1 by 2 dx. Integral minus 2 plus 2 sine square x by step of x by pi plus 1 by 2 dx. So in the last session I told that whenever the limits are in the form of minus a2 plus a, first of all we have to check whether the given function either even or odd. Okay, so let us check. Here f of x is equals to given function sine square x by step of x by pi plus 1 by 2. Step of x by pi plus 1 by 2. So to check the given function is either even or odd, we have to find out the value of f of minus x. That means substitute minus x in the place of x. F of minus x is equal to, so sine square of minus x, of course sine of minus x is minus nx. So sine square of minus x is minus nx whole square, it will become plus sine square x. There is no change at all. Whole by step of minus x by pi plus 2. Step of minus x by pi plus 2. Instead of x, you have to substitute minus x. Sine square of minus x becomes plus sine square x. Step of minus x by pi plus 1 by 2. Achha. So we have property for step x. Step of minus x is equals to minus 1 minus step x. If x does not belongs to I. If x does not belongs to I, step of minus x is equal to minus 1 minus step x if x does not belongs to I. If x is not an integer, then step of minus x is equal to minus 1 minus step x. Here, what is there in the place of x? X by pi. X by pi. So if x by pi is an integer, then x must be a multiple of pi. Then only x by pi is an integer, otherwise it won't be integer. Here, the limits are minus 2 to plus 2. The limits are minus 2 to plus 2. In between minus 2 to plus 2, there is no multiple of pi. Why? Because the value of pi is 3.14. Right? The value of pi is 3.14. That means in between minus 2 to plus 2, there is no multiple of pi. That means in between minus 2 to plus 2, x by pi never be an integer. Never be an integer. So therefore, x by pi does not belongs to I. X by pi does not belongs to I. This never be an integer. Why? Because here x belongs to minus 2 comma plus 2. Right. So therefore, f of minus x is equals to sine square x by according to that concept, this can be written as step of minus x is nothing but minus 1 minus x. So step of minus x by pi is nothing but minus 1 minus step of x by pi plus 2, isn't it? Sorry, plus 1 by 2. This is plus 1 by 2. This is plus 1 by 2. See here, this is minus 1 and this is plus 1 by 2. Minus 1 plus 1 by 2 is nothing but minus 1 by 2. Okay, so f of minus x is equals to sine square x by, now see the denominator, this is minus step x by pi, this is minus 1 plus 1 by 2 is minus 1 by 2. Now the denominator is minus step of x by pi minus 1 by 2. So now this can be written as minus of sine square x by step of x by pi plus 1 by 2. Step of x by pi plus 1 by 2. Right? So what is the function? F of x is equal to sine square x by step of x by pi plus 1 by 2 now. So what do you get? Minus sine square x by step of x by pi plus 1 by 2. So this is nothing but minus f of x. That is nothing but minus f of x. So finally, what do you get? F of minus x is equals to minus f of x. F of minus x is equal to minus f of x. So now the property is integral minus a2 plus a f of x dx is equals to 0. Integral minus a2 plus a f of x dx is equals to 0 when f of x is odd. F of x is odd. This is very, very important property. Integral minus a2 plus a f of x dx is equals to 0 when f of x is odd. Sir, what is the property when f of x is even? In the last session I told integral minus a2 plus f of x dx is equals to twice integral 0 to a. What is that? Twice integral 0 to f of x dx if f of x is even. Okay, so therefore here the given function is odd function, so therefore the value of this definite integral is 0. So integral minus 2 to plus 2 sine square x by step of x by pi plus 1 by 2 dx is equals to 0. Right? So whenever the limits are in the form of minus a2 plus a, don't forget to check whether the given function is either even or odd. Okay, use this property. Clear? Right. I'll go for the next question. This is the next model. Integral minus pi by 2 to plus pi by 2. Integral minus pi by 2 to plus pi by 2 sine square x whole by 1 plus 2 power x dx. Integral minus pi by 2 to plus pi by 2 sine square x by 1 plus 2 to the power of x dx. Once observe the limits. So again the limits are in the form of minus a2 plus a. Minus a2 plus a. Here f of minus x is equal to sine square of minus x sine square x. The 1 plus 2 to the power of minus x. So can you write 2 to the power of minus x is minus 2 to the power of x? We can't. Can I write 2 to the power of minus x is plus 2 to the power of x? We can't. So here this function, if you find out f of minus x, that never be minus f of x or that never be f of x. That means here sine square x by 1 plus 2 power x neither even nor odd. So we can't apply the property there. Then what we have to do, sir? See, I is equals to, let us say, let I is equals to, this is equation number 1. Let I is equals to. So yeah, I am going to use the property. So the property is integral a to b f of x dx. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. This is called King rule. Integral a to b f of x dx is equals to integral a to b f of a plus b minus x dx. I am going to apply the property here. So that means I is equals to integral minus pi by 2 to plus pi by 2. Then what we have to write? See, here x is there. Here in place of x, what is there? A plus b. What is the meaning of a plus b? Upper limit plus lower limit. Upper limit plus lower limit minus x. See, in the given problem, upper limit is minus pi by 2, lower limit is plus pi by 2. If we add upper limit and lower limit, the value becomes 0. A plus b becomes 0. So according to this property, a plus b means 0. So x can be replaced with minus x. It is enough, right? So sine square of minus x, it is sine square x. Sine square of minus x, it is sine square x by 1 plus 2 to the power of minus x. 1 plus 2 to the power of minus x dx. Achha. So therefore I is equals to integral minus pi by 2 to plus pi by 2. Integral minus pi by 2 to plus pi by plus 2 by 2. Here 2 power x, 2 power minus x can be written as 1 by 2 to the power of x. 2 to the power of minus x is 1 by 2 to the power of x. Take the LCM. So it will become 2 power x sine square x whole by, after taking LCM, 1 by 2 to the power of x. So you will get 2 power x plus 1. So it is 1 plus 2 power x dx. 1 plus 2 power x dx. Let us say this is equation number 2. This is equation number 2. So now I am going to equation number 1, add equation number 1 and equation number 2. Remember, so when the limits are same, then only we can add two different integrations. Otherwise we can't add. So here the limits are minus pi by 2 to plus pi by 2. Here also the limits are minus pi by 2 to plus pi by 2. So we can add equation 1 and equation 2. So 2i. This is I and this is I. 2i. The limits are same now. Integral minus pi by 2 to plus pi by 2. Integral minus pi by 2 to plus pi by 2. So once observe, what is the denominator equation 1? 1 plus 2 to the power of x. In equation 2, the denominator also 1 plus 2 power x. So 1 plus 2 power x denominator. In the numerator is sine square x, here 2 power x sine square x. So take sine square x common. If you take sine square x as a common term, here 1 is there, plus here 2 power x is there. After adding, this is the term. Here 1 plus 2 power x, 1 plus 2 power x gets cancelled. So finally, what do you get? 2I is equals to integral minus pi by 2 to plus pi by 2 sine square x dx. Integral minus pi by 2 to plus pi by 2 sine square x dx. Right. See, now again the limits are in the form of minus a to plus a. Here clearly sine square x is an even function. Sine square x is an even function. So nethi మీద power even unte it is always even function. So it is always even. So according to that property, 2I is equals to, this can be written as twice integral 0 to pi by 2. Why you wrote like that? Because sine square x is an even function and the limits are in the form of minus a to plus a. So you can write twice integral 0 to pi by 2 sine square x. Sine square x. Then how do we integrate sine square x? All are important. All are important. Every point is important for in the point of JEE mains U. So how do you integrate sine square x? How do you integrate cos square x? How do you integrate sine cube x? How do you integrate cos cube x? So very important. So we have integration for sine x. We have integration for cos x. We have integration for secant square x. We have integration for cosecant square x. We don't have integration for sine square x. So how do you integrate for integrating sine square x? We have to write the formula without having the powers. That means we have to reduce the powers. So is there any formula for sine square x without having powers? Yes, we have. Of course, here 2 gets cancelled. So I is equals to integral 0 to pi by 2 sine square x formula 1 minus cos 2x by 2. The formula of sine square x is 1 minus cos 2x by 2, right? So I is equals to, here 1 by 2 is a constant. You can write outside of the integration, this by 2. What is integration for 1? X. What is integration for 1? X. Here the limits are 0 to pi by 2. Here the limits are 0 to pi by 2. Now what is the integration for cos 2x? The integration for cos 2x is sin 2x by 2. So the 1 by 2 into sin 2x. 1 by 2 into sin 2x. Limits are 0 to pi by 2. So I is equals to, here if you apply upper limit it is pi by 2, if you apply lower limit 0, 1 by 2 into pi by 2 it is pi by 4. It is pi by 4. Here if you apply upper limit sin 2 into pi by 2 sin pi, the value of sin pi is 0. If you apply the lower limit sin 0 0, so total value 0. The final answer of I is equals to pi by 4. So the answer for this question is pi by 4. Okay, so these are all the previous mains questions. Remember, these are all the previous questions. Okay, like this. Easy question. Easy question. It is not a tough question. If you remember this property, if you apply this property, it's a very, very easy question. If you don't know the integration of sine square x, it is tough question. If you don't know the integration of sine square x, it is tough question. Clear? Okay. Next question is like this. Integral 0 to x f of t dt. 0 to x f of t dt is equals to x square plus integral x to 1 t square into f of t dt. T square into f of t dt. Then he is asking about f dash of 1 by 2 is equals to how much? Integral 0 to x f of t dt is equals to x square plus integral x to 1 t square into f of t dt. Then f dash of 1 by 2 is equals to how much? So this is another model, indefinite integration. So this question is based on Leibniz rule. What is that? Leibniz rule. So let me write the formula for Leibniz rule. This is not the time to discuss all the proofs. Leibniz rule. The formula is like this. Integral phi of x to psi of x. Integral phi of x to psi of x. F of t dt. Integral phi of x to psi of x f of t dt. That means here the limits of this different integral are in terms of x. The limits are in terms of f x, and this is some other variable other than x. Here the limits are in terms of x. Here the function is in terms of t. Here the variable of integration is t. Here the variable of integration is t, and the limits are in terms of x. So now I am going to differentiate this definite integral with respect to x. With respect to x. Why? Because here the limits are in terms of x, then you have to differentiate with respect to x. That is the process of Leibniz rule. If the limits are in terms of y, so you have to differentiate with respect to y. Right. So d by dx of integral phi of x to psi of x f of t dt. F of t dt. Suppose, for example, d by dx of integral of f of x dx. Integral of f of x dx. Here this is an indefinite integral, that is not a definite integral. So it is very easy. D by dx of integral f of x is nothing but simply f of x. Simply f of x. Integration and differentiation both are gets cancelled, because inverse integration is the inverse process of differentiation and vice versa. So d by dx of integral of f of x dx is f of x. Okay. So, but in definite integration, it should not be like that. In definite integration, the limits are same, limits are there now. So this is the process. See, very easy, very easy. Here, what is the upper limit? Psi of x. And what is the variable of integration? T. Upper limit is psi of x, variable of integration is t. So first apply the upper limit. Apply the upper limit. That means write upper limit in place of variable of integration. So that is f of what is the variable of integration? T. So in place of t, write upper limit f of psi of x. After applying the upper limit, find out the derivative of upper limit f of psi of x into psi dash of x. F of psi of x into psi dash of x, upper limit, minus, apply the same process for the lower limit, f of phi of x into the derivative of lower limit. First, you have to apply the upper limit and then into the derivative of upper limit minus f of lower limit into the derivative of lower limit. So very simple. F of upper limit into derivative of lower upper limit minus f of lower limit into derivative of lower limit. This is called Leibniz rule. This is called Leibniz rule. Frequently, you are asking the questions based on Leibniz rule in mains. So this is the question based on this Leibniz rule. So here the limits are in terms of x. Here also the limits are in terms of x. So integral 0 to x f of t dt is equals to x square plus integral x to 1 t square into f of t dt. Here the limits are in terms of x. Here also the limits are in terms of x. Now I am going to differentiate with respect to x on both sides. Differentiate with respect to x on both sides. See, here the variable of integration is t. Here the variable of integration is t and the upper limit is in terms of x. Of course, upper limit is x. So now according to this formula, first of all, we have to write upper limit in the variable of integration, that is f of x into what we have to do? Derivative of upper limit. Upper limit is x, derivative of upper limit is 1. Minus, we have to apply the lower limit, of course f of 0. After that, into derivative of lower limit. Lower limit is 0 now. 0 is a constant, right? So derivative of 0, 0 again. So this term becomes 0. So f of x into 1. So the derivative of this function is completed. Now come f of x, x square. The derivative of x square is 2x. Its general derivative plus. Now again, this is a definite integration. So definite integration key, you have to apply Leibniz rule. So here the upper limit is 1. Upper limit is 1. So first you have to apply the upper limit. It's 1 into f of 1 into the derivative of 1. The derivative of 1, 0. So this is 0. Minus. Apply the lower limit. Tell me x square into f of x. X square into f of x. X square into f of x into the derivative of lower limit 1. The derivative of lower limit 1. Achha. So take this minus x square to this side, minus x square into f of x to this side. So f of x plus x square into f of x is equals to 2x. Is equals to 2x. So take f of x as a common term. So from this, f of x is equals to 2x by 1 plus x square. F of x is equals to 2x by 1 plus x square. So by using the Leibniz rule, you get the function f of x. F of x is equal to 2x by 1 plus x square. What he is asking, f dash of 1 by 2. So can't we differentiate this one? F of x is equal to 2x by 1 plus x square. No, so simple. So differentiate with respect to x. So what is the derivative of f of x? F dash of x is equals to, which rule you have to apply here? U by v rule. Tell me, 1 plus x square into the derivative of 2x is 2. The derivative of 2x is 2 minus 2x into the derivative of denominator 1 plus x square derivative is 2x whole by 1 plus x square whole square, 1 plus x square whole square. So finally f dash of x is equals to like this. So 1 into 2, 2, this is plus 2x square, that is minus 4x square. 2x square minus 4x square is minus 2x square whole by 1 plus x square whole square. Like this, we can find out f dash of x. But he is not asking about f, he is asking about f dash. Just substitute 1 by 2, automatically you will get your answer. Okay, so this is the way to apply Leibniz rule. So very important rule, indefinite integration. Very, very important rule. Integral phi of x to psi of x, derivative of integral phi of x to psi of x f of t dt is equal to f of upper limit into the derivative of upper limit minus f of lower limit into derivative of lower limit. Okay, right. The next question is like this. Let a function f maps from closed interval of 0, 3 to r be a continuous function, such that f of 1 is equals to 3 and capital F be defined as capital F of x is equals to integral 1 to x t square into g of t dt, integral 1 to x t square into g of t dt, where g of t is equals to integral 1 to t f of u du, g of t is equals to integral 1 to t f of u du. Then for the function, for capital F comma at x is equals to 1, for capital F at x is equals to 1, the options are like this: a point of local minima and no critical point, a point of inflection, a point of local maxima. So he is talking about local minima, local maxima, no critical point and critical point, like this. So let us see what is the information he has given. First of all, capital F of x he has given. What is that? Integral 1 to x t square into g of t dt. This is the first thing he has given. And also he has given that g of t is equals to integral 1 to t f of u du. So this question was asked in 2020 January mains. This is a 2020 January mains question. Okay, see, it's a very, very important question. See, in this question there are a lot of concepts are covered in this. Just listen carefully. F of x is equal to integral 1 to x t square into g of t dt. Okay, so first differentiate with respect to x. F dash of x is equals to, tell me which rule I am going to apply in RHS? Leibniz rule again. So here what is upper limit? X. That means what is the variable of integration? T. So in the variable of integration we have to substitute upper limit. So that is x square into g of x into the derivative of upper limit, that is x, the derivative of x is 1, minus lower limit is 1 now. So lower, if you write lower limit 1 into g of 1, and after that you have to find out the derivative of 1 now. What is the derivative of 1? 0. So no need to write the next one. So capital F dash of x is equal to x square into g of x. Okay. So that is nothing but capital F dash of x is equals to x square into, what is g of x he has given? Sir, g of x, where is g of x, sir? He has not given. It's given, no? That is g of t, sir. If g of t is given, automatically g of x is also given. Instead of t, write x. That's it. So g of t is equals to this one. Then g of x is equal to integral. Write t in place of x. Write x in place of t. That's it. Replace t only. So g of x is equal to integral 1 to x into integral 1 to x f of u du. F of u du. This is f dash of x. This is f dash of x. Right. After that, Malli, again differentiate with respect to x. Differentiate with respect to x. The derivative of f dash of x is f double dash of x. The derivative of f dash of x is f double dash of x. See here, this is x square into na. So x square into integral 1 to x f of u du. So I am going to differentiate with respect to x RHS. So this is in the form of uv. So for RHS you have to apply product rule. So apply. So x square into the derivative of this one. The derivative of this one. Again for this you have to apply Leibniz rule. Correct. So Leibniz rule. So here what is the variable of integration? Sorry, variable of integration is u and the upper limit is x. So write x in the variable of integration. So that is x square into f of x. X square into f of x, and the derivative of x is 1. Derivative of x is 1. And lower limit is 1. So next term becomes 0. So x square into the derivative of this definite integral is f of x plus integral 1 to x f of u du, integral 1 to x f of u du into what is the derivative of x square? 2x. What is the derivative of x square? 2x. So what I have calculated? I have calculated f dash of x and f double dash of x. So why you calculated f dash of x and f double dash of x, sir? What is the purpose, sir? Let me explain. For maximum or minimum, at x is equals to 1, then f dash of 1 must be 0. If f dash of 1 is equals to 0, then we can say that the function f of x have either maximum or minimum at 1. Right. So now f dash of x is this one, So calculate f dash of 1. I'm going to calculate f dash of 1. If it is equals to 0, then the function may have either maxima or minima at x equals to 1. So f dash of x, this one, f dash of 1, write 1 in the place of x. Here 1 into integral 1 to 1. Whenever in a definite integration, upper limit and lower limit are same, then the value of definite integral becomes 0. In a definite integral, if the upper limit and lower limits are same, then the value of that definite integral becomes 0. So therefore, f dash of 1 equals to 0. Clear? F dash of 1 equals to 0. That means clearly the function f of capital F of x have either maxima or minima at x is equals to 1. So who says at x is equals to 1 the function have either maxima or minima? So the second order says. So now I am going to calculate. F double dash of 1. Here f double dash of x is there. So calculate f double dash of 1. So f double dash of 1. Write x in the place of x. So sorry, write 1 in the place of x. So 1 into f of 1. That is f of 1. That is small f of 1. Plus integral 1 to 1. X is here only. Integral 1 to 1. Upper limit and lower limit are same now. The value of that different integral becomes 0. So 1 into f of 1 plus 0. So what is the value of f double dash of 1? That equal to f of 1. He has given f of 1 value as 3. So f double dash of 1 is equals to 3. So f double dash of 1 equals to 0 and f double dash of 1 equals to 3. That means the first order derivative of capital F of x at x is equals to 1 is 0. And the second order derivative of f of x at x equal to 1 is 3. That is positive. If first order derivative 0 and the second order derivative positive, then at that particular point the given function has a local minima. If first order derivative 0 and the second order derivative negative, if the first order derivative 0 and the second order derivative negative, and at that particular point the given function has a local maximum. So for maxima minima, first order derivative 0, if f of second order derivative negative, at that particular case the the function have local maximum. If the second order derivative is positive, in that particular case the given function has local minima. So like this, so you can discuss the problems in the definite integration. Right. So discuss all these, revise all these models once again. So basic problems based on modulus, problems based on step function, problems based on even and odd function, problem based on properties, problems based on Leibniz rule, and problems based on summation of series. These are the 6 models which are very important for indefinite integrations. Come again, problems based on modulus function, problems based on step function, problems based on Leibniz rule, problems based on even and odd functions, problems based on properties. Properties means integral 0 to f of x dx, integral a to b m integral 0 to 2f of x dx is equal to twice integral 0 to f of x dx. Once revise all the properties. Okay. So right, these are the important models in definite integrations. So keep watching the videos. These videos are very useful to crack the JEE Main 2020. Okay, don't miss the videos. In the next video, we are going to discuss about the next chapter, that is areas. Okay, so if you like this video, please share and don't forget to subscribe. Okay, keep watching. Thank you. Bye bye.